The lesson outcome for this video is I can use all 7 power rules. Okay, so just a quick refresher on the 7 rules, and I'm going to write 7 rules down if you want to pause the video and try all of them on your own quick and just jot down what you think the answers are and then check back to see how you did. These are just going to be our basic rules, and then we're going to do another slide on some more challenging ones. Okay, so go ahead and try these. Okay, so how did you do? Let's check these. X to the third times x to the fifth, we keep our base of x and we add the exponents, so x to the eighth. X to the third to the fifth, one base raised to 2 exponents, we're going to multiply the exponents, so x to the 15th. This next one, if we've got x to the third in the numerator and x to the fifth in the denominator, we have more x's in the denominator. And how many more do we have? We have 2 more in the denominator than we have in the numerator, and we need to fill in the top with 1. This one, we are going to make sure each factor in the parentheses gets raised to the third power. This one over here, same thing. We're going to make sure everything in the parentheses gets raised to the third power. Anything raised to the 0th power is 1. And our last one, anything with a negative exponent needs to be moved to the opposite side of the fraction and make that exponent positive. So x to the third stays because it's got a positive exponent. Y to the negative 5, we move it to the top, the numerator, and we make the power positive. And we can fill in the bottom with a 1. How'd you do? Okay, so now here are some more complicated ones using those rules. If you could pause the video, try these out, and come back to check how you did, that'll be the best thing for you. If you don't feel prepared to do that, go ahead, just watch me walk through them, and then just keep practicing. Okay, so the first one. First one, we're going to say, all right, the 5, I don't have anything to cancel or reduce or simplify that 5 with, so we're going to leave the 5 there. Where do I have more x's? If I expanded them, I have more in the numerator, so x squared, because I have 2 more in the numerator. Where do I have more y's? Again, in the numerator, so I'm going to put y in the numerator, and I have 1 more in the numerator, so I could put this 1 here, but I wouldn't have to. Okay? The denominator then is just going to be filled in with 1, and this is our final answer, or if you'd like to write it as 5x squared y, that would be fine as well. The next one. Every factor in the top and the bottom, the numerator and denominator of the fraction, needs to be raised to the third. So 3 gets raised to the third, x to the second gets raised to the third, and in the denominator 4 gets raised to the third. 3 to the third is 3 times 3, which is 27. X to the second to the third is x to the sixth, and in the denominator 4 to the third power is 4 times 4 times 4, which is 16 times 4, which is 64. One last thing, we can reduce or simplify our fraction if possible, which in this case is not. So this is our final answer. Okay, 0 exponent rule here. Remember, this entire thing is being raised to the 0, so the entire thing turns to 1. The next one, we have a negative exponent, so we're going to always write this as a fraction. 2 will stay in the numerator because it is not being raised to a negative exponent. The x to the negative 2 is, so we're going to move that to the bottom of the fraction, the denominator, and make the power positive. So 2 over x squared. The next one, we have x squared to the 4th power, which means we need x to the 8th, because 2 times 4 is 8. And then we're going to multiply that by 3 and times x to the 5th. Notice 3x to the 5th is not stuck together any more than anything else would be, even with this kind of multiplication symbol. So it's all multiplication. So at this point, we can simplify one step further by writing 3 and then saying I do have a base of x with 2 different exponents, and I can add those exponents because I'm multiplying our x terms. So x to the 13th. Okay, so 2 more examples, just a little bit more complex than the previous page. We'll see how much you can handle here. So first of all, notice there's no exterior parentheses with a -2, for example, like this one on this example. So we are just ready to start simplifying. All right, so I'm just going to write equals and put a fraction bar. All right, so one mistake people make is they think this -2 is a power for the 3 as well. But remember, the 3 just has a 1 power, so we're going to leave that in the numerator. And then the next factor is x to the -2. Since it has a negative exponent, we're going to move it to the denominator, and we're going to make the power positive. The y to the 3rd power doesn't have a negative power, so it's going to be left where it is. Then we have z to the -1, and it has a negative exponent. So we're going to move it to the other side of the fraction, and we're going to make the power positive. Now we go to the denominator, and we're going to do the same thing. So again, if it has a negative exponent, we move it. If it has a positive exponent, we leave it where it is. Now, the 4 has, again, a 1 exponent. So the 4 is going to stay where it is. Now, when I write it in my answer, I'm actually going to write it in the front, because that's where I like my number bases. All right, now I have x to the 3rd. That is going to stay where it is. So x to the 3rd, because it doesn't have a negative exponent. Then we have y to the -5th, which will move and make the power positive. So y to the 5th, positive 5. And then x to the -2 is also going to move to the numerator, and we're going to make the power positive. So x to the 2nd power. All right, now we're going to simplify this further. What you have to look for here is like bases. The 3 and the 4 are our numerical bases, and we cannot simplify 3 over 4, so that's actually going to stay. The 3 and the 4 will stay. So now, it doesn't matter what order you kind of do this in, but right here I see a base of y and a base of y, and so I'm going to add their exponents because they're both in the numerator. So I'm going to get y to the 8th power. The next thing I see is I see an x squared right here. Do I have any more bases of x? Well, yeah, I actually have 2 more bases of x down here. So maybe in this next step I'll actually combine these and then deal with that one in a minute. So down here, so I'm going to actually, what I'm going to do is I'm going to leave my x squared just for the time being. And there's different orders to do this. This is just the way I'm progressing. All right, so now down here in the denominator I have a base of x and a base of x. So I need to add their exponents. So that's x to the 5th. And then I have z to the 1st in the denominator, and that's the only z. And actually I don't have to write the 1st power there if I don't want to. And now we are almost done. So close. But what's going to happen is we're going to be able to simplify one last time because I have a base of x in the numerator and a base of x in the denominator. Where do I have more x's if I were to expand that? In the denominator. How many more? 3 more. So I'm going to end up with, I'm going to leave my 3 here, and my y to the 8th here. Now my x squared, I'm not going to write that anymore because I'm saying I have more x's in the denominator and I have 3 more. So I'm going to write x to the 3rd in the denominator. The 4 is going to stay down there as well, and the z. This is our solution, or our simplified answer. So just one more, and if you would like to pause the video and try this one on your own for a challenge, that'd be great. If you'd rather just watch me, go ahead and do that. All right, so the first thing, everything in the parentheses needs to be raised to the -2. That's how I start this problem. Again, there is more than one way to solve this or simplify this. So I'm going to write 5 to the -2, x to the -2, y to the -3 to the -2. Every factor got raised to the -2. And in the denominator, 2 to the -2, x to the -4 to the -2, and a y to the -2. I didn't need parentheses there, I now notice. And z to the -3 to the -2. That might seem a little crazy at first, but we're going to be able to simplify this. So the first thing I'm going to do at this point is I'm going to simplify using my power of a power rule. Okay, I'm not going to deal with this yet or this and move things. I'm going to simplify the power of a power rule for each of these. Okay, so I'm going to leave my 5 to the -2 alone. I'm going to leave my x to the -2 alone. And now I've got y to the negative 3 to the negative 2, which means I multiply those exponents and I get positive 6. In the denominator, I have 2 to the negative 2. Then I have x to the 8th, because x to the negative 4 to the negative 2. We're going to multiply the powers, which is positive 8. And then we have y to the negative 2, negative 2. And then we have z to the positive 6. Again, negative 3 times negative 2. All right. Now, I'm going to come back over here. I'm going to write my fraction bar. And now I'm going to decide if things stay or move. Each factor, we decide if it's going to stay or move based on if it has a negative exponent. This has a negative exponent, so I'm going to move it and make the power positive. So 5 to the 2nd power. This has a negative exponent, so I'm going to move it and I'm going to make the power positive. So they're both in the numerator, now they're both in the denominator. This has a positive exponent of 6, so we're going to leave that where it was. So y to the 6th. In the denominator, we have 2 to the negative 2. We need to move it and make the power positive. So it's currently in the denominator, so I need to move it to the numerator. And again, I like to put that in the front, 2 to the positive 2 power. The x to the 8th that's in the denominator stays where it is because it doesn't have a negative exponent. The y to the negative 2, that's right here, y to the negative 2 is going to move, and we're going to make the power positive, so y to the positive 2. And lastly, we have z to the 6th in the denominator, and that's going to stay because it has a positive exponent. All right, we're going to do some more simplifying. First of all, 2 to the 2nd power, 2 squared, is 4. Y to the 6th times y to the 2nd means we have a base of y, and we add the exponents, so that will be 8. Again, not 12, but we're adding them. In the denominator, 5 squared is 25. X to the 2nd times x to the 8th is x to the 10th. And then we have z to the 6th. And this problem is now fully simplified.